Okay, so let's get rolling. Get my screen up here. All right. And again, thanks for everybody who showed up to some or all of the senior presentations. I think it made them pretty decent compared to what they could have been if they were just speaking to an audience of 4 or 5 people. And I think actually, as a whole, they were pretty good. There was, I think the average project was maybe a little bit better than it historically has been. You still had your weak ones, but in general, I thought they did a pretty decent job given the circumstances. All right, so let's spend a few minutes today first going over kind of what I plan on putting on the midterm. I'm sorry, the final exam. And then we'll go and look at the solution to the homework assignment. So let me scroll back. I mean, everything from earlier in the semester is fair game. In fact, let's just go back to the beginning here. You should definitely be able to work with pointers and memory and things like that. So, I mean, obviously, plan on your the usual conversion problem. You know, you should be able to move between any base and any base. You should also be able to convert between data sizes. So if I say that something is some number of megabits, you should be able to tell me how many kilobytes that is, that kind of thing. So these are skills that all computer scientists should have, and you should be prepared at any point in time to do that conversion. So remember, you have eight bits in 1 byte, and then there's 1,024 multipliers. You go up and down the chain. So there's 1,024 bytes in a kilobyte. There's 1,024 kilobytes in a megabyte. There's 1,024 megabytes in a gigabyte, so on and so forth. There's 1,024 bits in a kilobit. There's 1,024 kilobits in a megabit, so on and so forth. So it's not like it's a major memorization type situation. If you know the multiplier by 8, you know the multiplier by 1,024, you have everything you need. And then also going between number bases, you should be able to work with going between any bases. These are things that all computer scientists need to be able to do, regardless of class. Okay, so having said that, expect one conversion problem on there of some type. Let's see. Certainly be able to work with pointers in C++. That's something we've done heavily. Understand how arrays are put together and that kind of stuff. Be able to work with stacks, be able to work with queues, linked lists. The second exam here is probably going to focus more on the nonlinear linked data structures, but the linear linked ones will be fair game. That was going through our exam. I probably won't ask you like a specific question about an algorithm, like, shunting yard. I expected you to do that for the homework assignment, but I'm not going to ask you like something like show me the output queue of shunting yard when applied to some problem. While that is an interesting enough thing and proves you understand the shunting yard algorithm, that's not what this class is about. This class kept you working with data structures and algorithms and languages, and we applied it to the problem of shunting yard, but competency in the shunting yard algorithm is not an outcome of this class. Competency in programming and data structures is. All right, so I won't ask you questions about like a specific outcome from an algorithm. Recursion will make an appearance officially on this exam, at least in one question. I had an unofficial cameo on the midterm that I'm still recovering from the hate mail I got from that. So I apologize. Well, I don't really apologize, but yeah, no, I found it fun, I think. But in any case, it'll be on there for real this time. In one form, you know, again, you know, we applied it to merge sort in as an example in this class, but the exam won't cover merge sort. The exam is going to, I mean, you should be able to read code like merge sort and tell me what it does, or you should be able to write code probably simpler than merge sort from a recursion perspective, proving that you can kind of write things recursively with the understanding that even now your competency with recursion is going to be a little bit sketch. Hopefully all of you signed up for 470 in the fall, where you can, I promise when you come out of that class, you'll be pretty strong in recursion. So that's a cool class, and you might as well keep the programming stuff rolling. So in any case, if you haven't signed up for 470, strongly encourage you to do that. It'll be offered the following fall as well, but I don't think you want to take that class alongside senior seminar. It would be a kind of a rough semester, I think. So 470 for this coming fall, I think makes some pretty good sense. But you'll get very good at recursion in there, and that's where you'll really, really be tested on recursion. But I do expect you to have a, you know, a passing competency in it at this point. I won't ask you any bitwise operations. That was just that one example I kind of showed you. That's more of a 325 or a 450 type of competency, so that won't make it onto the exam. Certainly trees. Go ahead, Ben.
So I have a question regarding the nonlinear and linear data structures. Would it be possible for you to ask a question of which method to better use in a situation, since we did talk about that?
Well, I mean, definitely I could give you a scenario, and you know, kind of this is related to something we've done more recently, where I've given you, you know, somewhat open-ended homework assignments and had you try to figure out what was the appropriate data structures to use to solve the problem. So a fair game question would be, you know, me giving you a scenario. If you were to write a program to solve this, what kinds of objects, what kind of data structures would you use for solving the different parts? So understanding the differences between you know, linked lists, the stack, a queue, a binary tree, a graph. You know, these are things that would be, you know, important things. I probably wouldn't ask you kind of a canned question like, what kind of problems would you apply a binary tree to? I would probably either show you a binary tree and ask you, what is this guy doing? Or give you a scenario and say, tell me how you would solve this and explain why, where there might be multiple correct answers, but definitely incorrect answers as well.
Okay, yeah.
Yep. So,
all right.
Yeah,
thank you.
Yep. And again, you know, my exams, and hopefully you found this to be the truth up to this point, minus the recursion question on the last exam, is that, you know, I'm really testing competency, not memorization. So when I grade an exam, I'm looking at, does this person pretty much know what's going on? And, you know, a stupid little syntax error or something like that, not a huge deal. It's pretty clear when you look at somebody's code or somebody's answer, whether they pretty much know what's going on or whether they pretty much don't. So, you know, in questions like that, where I ask you to kind of give me your rationale for how you would solve this, you know, I fully expect to get, you know, weird but maybe well thought out answers from like Noah or something like that, where not everybody has to have the same approach to it, but your approach should have a rationale that is in the realm of sensical behind it. So with that in mind, there would be more than one correct answer as long as you were able to give me a rationale as to why you chose to do it a certain way. So with that in mind, when you're taking the exam, kind of remember that I'm looking for you to prove your competency to me, not searching for the what would Littman do answer necessarily, because sometimes my approach to something might not make tons of sense to you. It could be that my approach is weird. It could be it's an experience type thing and your comfort level is just in a different place. But my answer isn't necessarily always the best answer. It's what makes sense to me, or it's how I'd approach it, but you could have a perfectly reasonable full credit answer to that question that completely deviates from my approach, but you at least argued why you chose it instead of just saying, well, here's the 7 buzzwords I know. I just picked some of them and put them on this answer and hope for the best. So hopefully that makes sense. I care about competency. I don't care about perfection. Perfection will come as you debug your program and stuff like that. Okay, so understand trees. Know the binary tree rule where everything to the left is less than or equal to, everything to the right is greater than. Certainly be able to traverse a tree in the 3 different ways: in order, pre-order, post-order. So there will almost certainly be a question that has you walk a tree like that. And by the way, I assume that doesn't change very often, but that exact same question is on the big competency test at the end of 490 that you take with Dr. Locklear your last semester of your senior year. In order, post order, pre-order. So being able to walk a tree in the correct order that's a knowledge that all computer science folks should have. And I would be very surprised if that doesn't make a appearance on the exam in one form or another. Not so much necessarily writing the code for that, but if I gave you a tree and I told you to show me the order that the nodes would be visited in, if I said visit in post order, you should be able to answer that. I'm not going to ask you specific examples of, searching algorithms, but if I ask you to write some code that looks through some kind of data structure, an array, a linked list, or whatever, and returns the index of something, you should be able to do it. You should be able to write the logic to accomplish that kind of thing. So again, this is where I, started giving you the more open-ended assignments where, I really wanted you to consider the nature of a data structure. Something doesn't have to have a name in order to be a data structure. So if I give you a scenario, which I could almost promise you'll have at least one question where I give you a scenario and ask you to tell me how you would solve this. I might not even ask you to write any code. I might just say, kind of do the original planning process like we have with our players and our items and things like that, kind of explain how you'll store these different things. Once you go to do the code, you've already solved the problem. Now you're just kind of, doing the actual implementation. I won't ask you anything about the traveling salesman problem. That's more of a computer science historical thing. It's something you do cover in the 490 class. And hopefully you've recognized that our, assignment project we've been working on more recently kind of brings all these different things together where we're grappling with that idea of, well, when do I use an array? When do I use a linked list? When is it a graph? How do I go from one thing to another? How do I make these objects interact with each other? We're kind of looking at this, gamified example of all the things we dealt with throughout the semester. So when I say, tell me how you might solve a problem, I'm looking for things like this. Like, oh, a room has these fields and this is how I would store them. And this is why I would store my, maybe I store my collection of doors as an array because of this. I would store my collection of students as a linked list because of this. So on an exam, and if I asked you to explain how you would solve something, I'd want you to tell me, these are the fields that a guy would have, and this is how I would store those fields. And maybe if you need to have a certain method or something, but give me a rationale. It doesn't have to be a 10-paragraph dissertation on why that's your rationale. Just give me enough information to tell me that you know what you're doing. You know, again, I'm not impressed if you write 30 sentences. You know, it's pretty clear whether somebody is giving you a, you know, legitimate competence type answer that may or may not be a great answer, but it's at least coming from a position of competence that will only improve over time versus somebody else that really doesn't know what they're doing and they're just making stuff up hoping they use the right buzzwords. It's pretty clear to me which of the two answers I'm looking at. So don't feel like you have to write me a book. Give me as concisely as you think it needs to be in order to prove to me that you know what you're doing. Okay. So I'll just kind of throw a slide on here. So final exam will be 600 questions, all programming. You have 25 minutes to take it. It's my usual exam format, so 10 questions. I probably would guess about 6 programming, 4 other. Expect 1 conversion of some type. Throw it out there. It'll be all online using Blackboard. The exam will be up by end of day Friday this week. I actually hope to get it up today, but let's just call it end of day Friday. And you have to submit it by midnight next Friday. You must complete it in a single sitting. All right. I design almost all my exams to take about an hour. I'll put like a 4-hour time limit on this thing. So I don't want it to be a time crunch. I know some of you get extended time for exams and things like that. I don't think you need to worry about that. I'm basically just going to put a big number on it where you will finish the exam before the exam tells you you're done. I don't want it to be a time stress thing, but I'm going to design it to be about an hour. So you don't have to walk into this exam thinking that, oh, I'm going to spend the next 7 hours of my life working on an exam. It'll be about a 1-hour exam, but if you want to kick it around for 3 or 4 hours, that's up to you. It is closed book, closed note, closed friends, closed Google. If you want to use a editor or something like that to kind of give your code a little bit cleaner look, I think that's okay. I'm going to say no compiling and testing. And actually that has 2 rationales to it. On one hand is I'm not looking for perfection. If you have some syntax errors and stuff like that, I'm not taking off points for a nitpicky missing semicolon or something like that. Again, I'm grading for competency. It's going to be pretty clear to me whether you basically know what's going on or you basically don't. And I'm quite confident that if you're somebody who knows what's going on, once you go to compile it, you get your couple of errors, you'll debug them and, you know, move on with life. So that's not what I'm looking to take points away for. So do yourself a favor and don't waste your time compiling and testing, because I'm not looking for something that necessarily will definitely run. I'm looking for something that obviously is competent. But if you do want to use one of your text editors, the code looks formatted a little bit better, feel free to do that. You can paste your code in, or if you want to give me a link to a GitHub or something like that, that's okay as well. It's easier if you paste it in, but if you think it's going to be formatted really, really poorly, give it to me in a different format, an image or a detachment or something like that. But pasting it in will be the best if you can make that work out. but I'll figure it out one way or another. Okay, questions about the exam?
How much do you expect us to cry?
Well, I typically write it with the idea that I expect tears. And actually, you're encouraged for questions you can't answer to, as your solution, give me a picture of you crying. That's almost always worth partial credit.
All right, thank you.
But the last thing I want you to worry about is the time you have for the exam. I would say that you would be very, very, very conservative, setting aside 3 hours for the exam, but fully expecting to be done in an hour or less. But if you gave yourself a nice 3-hour block, you can sit there and stare at it for as long as you want, and you're just going to get tired of taking the exam, you know, before you're like out of time or something. So don't view it as a time commitment type situation, but I'm also not going to design it with it in mind that you have unlimited time. I'll design it as a 1-hour exam, and I'm just not putting a cap on the time other than whatever Blackboard, you know, forces me to do so it can, you know, submit the exam for you in case you forget to hit the submit button or something. All right, any other questions? Okay, so let's look at our final assignment that was due today. Hopefully it wasn't too bad. And hopefully you're recognizing now that you're actually becoming a better and better programmer. And while this is your last course in the official programming sequence, at this point, we're kind of turning you loose into the wild with a programming competence that hopefully most of you think that you wouldn't have had when you were in 200 and just kind of getting started with this stuff. You realize how much you've grown since then. But like I said, strongly encourage you to take 470 in the fall. While programming is still very much part of your mindset, because I think that's what turns you into a, let's call it a true computer scientist once you start thinking about how programming languages are built. That pulls all these strings together and I think makes things a lot more crystal clear. We have a lot of cool classes coming up. I realize you can't take every class under the sun, but you know, I would encourage you to do the 470 class and find a way to make that work, even if you have to watch videos and take it online if it doesn't fit your schedule. We can work that out, but I think it's a class that will benefit you greatly. And if you're switching to the new major, it's required for the software engineering concentration anyways, but even if you just take it as an elective, I think it's a legit good class. It's also my favorite class, and was my favorite class when I was a student. I took it, you know, a language theory class, and then it ended up being my research area, so it's fun. Okay, so add to Dungeons and Data Structures the ability for items to be inside of rooms and for students to be able to pick up items. A student should be able to drop items in a room, which will reduce the number of items the student has, and add that item to the room's collection of items. So basically, a room can have items, a student can have items. Students can pick up items found in a room, which would then remove it from the room and put it into the student's backpack. Or students can drop items, which would remove it from the student's backpack and add it to the room they're in. It just show up on the floor. Okay, so let's go back into okay, so right now, do we create an item? Yeah, we create a chainsaw, and we give it this name, a running chainsaw. and we just add that item to the student. So the student's able to add some stuff to their thing. So let's go look at the implementation of that. So add item takes in an item pointer, goes through. So as long as their current item count isn't equal to their max item count, so as long as they still have room in their backpack, go ahead and add it. Otherwise, we'll return false. So if we add it, we'll say backpack at bucket current item count gets the pointer to our item. And then we'll increment our current item count, return true. All right, so now we want to add the ability to a student to remove an item, given its name, from the their backpack. So we'll go into student HPP, and we'll say item pointer, remove item, string, item name. And we'll go into here. All right. So what we want to do is we want to go through our list of items. So we have current item count number of items. So for int I is equal to 0, I is less than this current item count, I plus plus. And we want to look at each item. So we want to say if the item we're currently looking at, which is this dot, what do we call them, items or backpack? This dot backpack at bucket I get name. That's going to be the name of an item. If that guy is equal to our item name that we're searching for, then we want to remove the item from our backpack. Okay, and removing it from our backpack is going to mean, so we're going to say item pointer, item to remove is equal to this backpack at bucket I. All right, so we'll give ourselves a pointer to that guy because we're going to end up overwriting him here in a second, because once we create a hole in our backpack, we want to move everything else up to close that hole because we're going to be reducing our current item count by 1. All right, so we want to go through the rest of our backpack, moving everything up by 1. So we're going to say int j is equal to I. We could use the variable I again, but I'll just use another counter to go through. So I'll start at bucket I, and I'm going to go all the way up to as long as I is less than this current item count minus 1, because we're going to be taking the next guy and replacing the current bucket with it. J plus plus, and this is J is less than, not I is less than. And then what we'll say is we're going to say this backpack at bucket J is equal to this backpack at bucket J plus 1. So we'll shift everything back down, keeping in mind that we already preserved our pointer to the guy that we're removing from our backpack. Okay. And then after we've done that, we'll say this current item count minus minus, and we'll return the item to remove. Now, if I get all the way here and I did not actually return an item, you know, I checked everything and the guy I was looking for wasn't there, then I need to still return something. So I'll go ahead and return a 0, a null value. Okay. So let's go ahead and let's test this. So before we start adding it to rooms and stuff like that, let's make sure that a player can remove something from their inventory. So we'll go back over to driver. And right now, backpack displays the contents of our backpack. So we should, here, let's create, we'll say the student, add item, new item. How do you spell machete? Is that it? Mr. Gonzalez just has buckets of weapons. He's carrying, so you've got to be prepared for anything. All right, so he has a couple of items now. So we're going to go through and we can give a command called backpack, and it'll show us the contents. So now let's go ahead and let's do an else if command is equal to, let's call it drop. All right, so this is asking us where would we like to go. So now we're going to say, what would you like to do? We're going to ask a little bit clearer question. What would you like to do? All right, so if we say drop, now realistically what we want to do here is we want to have drop be the first part, but then we want to take a substring from this guy to give us a piece of this string. So we're really looking for the first part of our command to be equal to drop. Okay, so what we're going to do here is we're going to have a little bit of, I'll just add a method here. So we'll create a method that returns a string called get command. And this guy will take a string as a parameter, and he's going to go through and he's going to build up everything up to the first space. So for int I is equal to 0, I is less than, what is it, s dot length. Is that a function or a field? It's like a function. I plus plus, and we'll say s plus equals, sorry, command plus equals s at bucket I. Now we want to ask a question here. We're going to say if s at bucket I is equivalent to a space, we'll go ahead and return our command. All right. We'll also return command out here, because for our commands like backpack and a north, south, west, whatever, those guys we're never going to find a space. Instead, we're just going to be building up command to be the same thing that S was, and we'll just ultimately return command here. Remember, return statements make a function immediately end. All right, so if I'm still kicking once I've checked every single character in my string, that means I never found a space in there, so I must have given it just a solid name. All right, so now what we want to do is we're going to have a second guy here. So string get, I'm going to call this guy get params from command. And this guy will take a string s as a parameter. And we're going to say string params. Start this guy off as the empty string. And what we want to go ahead and do is we want to get everything except for our command. So we want to get everything from the bucket after our space till the end. And I'm sure the string class has substring methods in it or whatever, but rather than go and looking that up, I'll just write it here real quick. So we'll real quickly say for int I is equal to 0, Actually, I'm going to do this. Int I is equal to 0 while S at bucket I is not equal to a space I plus plus. So it's when we exit this while loop, that means we finally hit our space. So I is looking at the bucket that is our space. So now we'll have a for loop. So we'll say for int j is equal to I plus 1. That's the bucket following the space. J is less than s dot length, j plus plus, params plus equals s at bucket j. Return params. All right, so this part right here gets us up to, takes I up to the position of the first space. This guy starts at the space right after that and goes all the way to the end of the string, building up everything except for the starting command. So for our backpack, our drop thing, this is the, you know, a running chainsaw would be our params. That's the name of our item that we want to pick up. Okay. So get params from command. Let's go ahead and test these two functions here real quick. All right, so we said cin to our command. So we're using cin to read into a string, but now we want to overwrite that string with command is equal to, what I call this guy, get command. From our command. So this will extract our command from it to get either backpack or a you know, a direction or the word drop, even though we'll say drop a running chainsaw. Okay. So if the command is equal to drop, then we want to say string params is equal to, we actually have an issue here. So let's actually read this guy into, instead of calling it command, let's call this guy command string. And we'll go ahead and have a string command and a string params. We'll set command. This guy will be our command string that we read in. He's the entire string. Then we'll set command equal to the get command from our command string. And then we might use params depending on our command. So if command is equal to backpack, do one thing. If command is equal to drop, then we want to go ahead and say params is equal to get params from command, and we'll pass this guy our command string. Because since we're in drop, we know that something follows the word drop, and that is the thing that we want to drop. All right, and in this case, we don't need to block it out anymore. We want the entire contents of what comes after drop. Okay, so now one thing we could do is if we want to clear any white space here, because we might have, I'll kind of show it to you as we go into this, we could update our get params to clear any leading white space or any trailing white space from our command. But we'll just assume they put decent stuff in for right now. So we'll get our params, and now we want to, why don't we just do a cout trying to remove params. All right, so we'll make sure that we're processing our command correctly. So let's go ahead and test this guy. All right, what would you like to do? We'll go ahead and type in backpack here, and we see our running chainsaw and our machete. And we'll go ahead and drop a running chainsaw. So this should flag our drop command and then say we're trying to drop a running chainsaw. Let's see, trying to remove. And we did not get running chainsaw from there. And then we also got a whole bunch of displays, but that actually could be how I'm currently doing my display. I'm not going to worry about that this exact second. Let's go back to driver here. So we definitely got into here, but get parameters. So let's do a cout command string. And let's make sure that guy is giving us a real thing. And I think it's because we have to initialize temp to an empty string in order to build onto it. All right, so we'll say backpack. That guy seems to be working. We'll say drop. I'll just say machete here. So we should see the command string is drop machete. Command string is just drop. So I had a bug up here somewhere. So we read in our command string. Then we use our command string to give us a command. Let me make sure that I'm not modifying S here in my get command. And I am not. That should give me a brand new thing there. So our command should be equal to something like drop, but then command string should be something that is whatever came in from our cin to command string. Let's test that. I'm thinking it's because I didn't give it a starting thing, but we'll find out here pretty quickly. And string still says drop. Kind of remember this from before. Wasn't this with our concatenation operator that it gives us a string? Didn't we need to do something special when we're concatenating? Go up
For
here.
CN, I was having trouble with the spaces.
Oh, so it was only reading in up to the first space?
I think so, yeah. So like for a running chainsaw, I had to just make it chainsaw.
I understand. But if that's the case, well, then but in our case here, I'm trying to say drop chainsaw, not just chainsaw, right? I'm trying to still say two words. So
Yeah, for mine, I just had it, you type in drop and then you'd CN again and then the name.
sure.
But
Oh, let's just do a man on, there is no manual page for CN. But Okay, to get the entire line, we have get line that takes in CN and the string. Okay. So that would be this guy. Get line, CN, and command string. What would you like to do? We'll say drop machete, trying to remove machete. So now this guy seems to know what's going on. Okay. So yeah, we had to use get line to get everything from that line. So now we should have our pieces. And it should have said trying to remove. We got our params. So now we'll go ahead and tell our player, so the student, what is it, remove item, params. All right, and what we'll do is we'll say if this works, because remember we're returning the item that we're dropping. So actually, let's go ahead and let's put it into a dropped item is equal to remove that item. Then we'll ask the question, if dropped item, if that guy's a thing, that means we actually drop the item. Because remember here in room, or actually it's in student, we return null if we were not able to find the item we want to drop. So if we return something real in here, then we want to do something with it. So if it's real, what do we do with dropped item? For now, we're just going to do cout success. All right, so we'll say drop machete. It says success. So now if I do backpack, it should only show me a running chainsaw. There's my running chainsaw. If I say drop a running chainsaw, it says success. If I say backpack, it should show me that it's empty. So we have nothing in there. Probably should have an alternative there to prove to us that it's empty. So for display backpack comments or contents, we'll just say if this current item count is equal to 0, cout empty backpack. And then we can go ahead and return, which makes the method immediately end. Otherwise, we can do all this stuff. I know a lot of people like to actually see the else. But it's not required since we're only still alive here if we didn't return here. All right, so now it'll detect if our backpack's empty, we give you some sort of feedback rather than printing out nothing. So there's our full backpack. We'll drop a machete. We'll drop a running chainsaw. And then we'll show our backpack again, and we have an empty backpack. Okay.
I have a question.
Sure.
So with the get line, so it takes in CN and then a string. Does the string's first occurrence have to be within get line?
It does not. So I defined it, where's my driver here? So I actually defined command string up here, and then I passed it into our get line down here. So what a lot of times you see in, this is something that's kind of left over from old C libraries, where you'll have a function like this that, maybe in this case it says, where am I reading it in from? And this guy a lot of times is called a buffer. So it'll end up coming in as a pointer to something. In this case, it's a pointer to a string, and it'll fill that guy up with the value such that after this line, this place in memory has been permanently changed. So he had side effect. This guy's being passed by address. And because he's being passed by address, changes that are made to him inside of this get line function will be noticed out here. So this function here says, where am I reading in from? And then where do you want me to put what I read in? Does that make sense?
Yeah, thank you.
But that pattern is a common pattern in older C programs, where you'll see reading things into a buffer. Instead of us writing a function that says read something in and having it return the thing it read in, a lot of C things were void, or they returned a Boolean or an int for whether it worked or not. And instead you would say, read something in, like I bet you that get line actually probably does return a value as to whether or not it worked. Where is get line here? I'm gonna guess it returns an int. Is it in yeah, see, it's actually from standard IO, get line, and what it does is it returns the size of what it read in. So it returns 0 if it read nothing in. Looks like there's also a get delimiter that allow you to also break things up. So that'll make, if we chose to use it, it'll make life easier, but whatever, we'll just write the stuff ourselves. All right, so now we can drop a bunch of stuff, and that seems to be working. So we can see our command is working. So why don't we're going to steal this line. If it worked, we're just going to say, you dropped a whatever. All right. And if we're in here, since we dropped something, we then need to add it to our room's list of items. So I'm going to go into room HP. Actually, I'm going to start off with student HPP. And I'm going to steal his item pointer.
I have a question on that.
Sure.
So, well, I guess it's not really a question, but could you explain that pointer again?
No, I don't understand it.
So my understanding is it's pretty much an array.
It is. Okay, so let me do it this way. Pointers as arrays. So first of all, saying it pretty much as is an array is false. It is an array. So if I say int AR of size 10, this guy is the same thing as me saying int pointer AR is equal to malloc 10 times size of int. These produce identical things. That make sense? So an array is a pointer of a type that it's holding. So AR is something that holds this kind of value. It holds integers. Okay? So the reason AR's type is an int pointer is because the way arrays work is we remember the base address of the array, and then we use offsets from there to walk through the buckets of our array. So this guy here, that last star, says this is an array. And it's an array that's holding these kind of things. Just like if I said item pointer AR is 10, I would say item pointer AR is equal to malloc 10 times size of an item pointer. The kind of value that this array holds is an item pointer. The kind of value that this array holds is an int. Both of them are arrays because of this last asterisk. That makes sense? An array
Yeah, that makes.
is always a pointer to the base address of its collection.
Okay. Yeah, that makes a lot of sense. Thank you.
Okay. Yeah, I know that this syntax can be a little bit intimidating, but this guy right here is the type. That's what he is. This is the type of value our array holds. This is what says he's an array, because AR is going to hold the address that is the base address of that collection. Okay, so going back over here, we are including, what am I including? Where am I? What am I here for? So we're including item HPP. And we're going to say that a room has a item pointer. Maybe we call this guy collection of items. Now we can decide that he's going to have a certain number of items in there, some maximum number of items. But instead, we can go ahead and allocate him to have a certain number of items. Now, what's interesting here is, why didn't we do that for students? Do we have in the constructor it take in the size of their backpack? Oh yeah, max item count. We set to 10, and then we use, oh yeah, because we need to know the max item count for that guy. Got it. All right, so we'll do the same thing with room. So this guy's going to have a collection of items. It'll have an int max item count, and it'll have an int current item count. And at this point, those guys are actually identical to each other. So I'm going to go into student, and it's going to have a add item and remove item and display backpack contents. I'm going to rename backpack contents a little bit to be more appropriate for a room. So a room will have maybe display items. Otherwise, it'll have add items and oh, this is add item. So then I'll go into my implementation over here. I don't want to forget for my room in the implementation, I need to set in the constructor the max item. So this max item count is equal to, I don't know, how many items do we want to let a room have? 100? Just have a pile of weapons in Mr. Gonzalez's arsenal. So it doesn't really matter what we put here. It just use up more memory. So we can say that a room can have a maximum of 100 items in it. And then we will say this current item count is equal to 0. Then in our constructor here, we will then say this collection of items is equal to malloc, this max item count times size of an item pointer. And this guy's coming out as a void pointer, so we're going to convert it to an item pointer. Okay. So that's what our collection of items will be. Now, technically, this guy lives in standard lib. I must be getting it from one of my other things. Maybe it's from IOStream or something, but so it looks like malloc, it knows about malloc here. So I'm guessing IOStream uses standard lib. So that's why it knows about this guy. Just to prove that, if I come out here and I look at the man page for malloc, it shows me that this guy lives inside of standard library. Okay, so there's our collection of items, and now I can go into student, the implementation, and I can steal a whole bunch of his stuff. There's remove item, there's add item. And then we'll go into our room, CPP, and we will add these guys down here, but instead of, so it's display, I call it just display items, but this is owned by room now. Okay, and it's no longer called backpack, now it's called collection of items. But because we have them working identically, adding and removing an item from our room is the same thing as adding and removing an item from our player. And we'll talk about inheritance here in a second. We won't cover it. You know, we did that in the Java class, but you know, the idea is that, you know, maybe since there's some commonalities now between rooms and players, they maybe both inherit from some parent class that knows how to hold collections of things, collections of items, because they have that in common, since they're both, you know, duplicating some code, but given time, we'll just say this is good enough. All right, so that's remove item there, and then add item is here. And then what we'll do is inside of a room's display function, here's its display function, we're showing the obvious exits. So we're going through all those. We're showing also here, we're going to show all of the students. And then we'll also go ahead and say this display items. To show the items that are laying around on the ground there. In fact, actually, we'll kick it down a line first. Then we'll display items. Then we'll kick it down another line. And display items. Yeah, for this guy, we actually don't want it to display empty backpack and we don't have any items. So we actually only want this part. And what we'll do is we'll do a see out items. See items here, something like that. Then we'll go through and display all the items. And why don't we just put a space between each of them? Actually, let's put a comma space between each of them because some of them are going to have spaces in them themselves. And then we'll do a see out \n, kick it down a line. All right, so now back here in go ahead and run it. Okay, so we have Mr. Gonzalez is here. We have 0 items here. If we type in backpack, we see that Mr. Gonzalez has some stuff in his backpack. We'll go ahead and say drop machete. The machete is now dropped. Oh, hold on. We're not actually adding it to the room yet. We've added the ability, but we haven't written it into our room. So here in our drop command, here's the item we're dropping. Now we need to actually tell the current room that we're in. So we'll say the student, get current room, add item, dropped item. And now that item should show up in the room. All right, so backpack, we'll say drop machete. And now we see that the room has a machete in it. And our backpack has just a running chainsaw. If we see drop a running chainsaw, we dropped it. Now we see that the room also has a running chainsaw. All right, we can clean up the extra trailing comma or something. That's just output type stuff. All right, so now the last thing we want to be able to do is we want to be able to pick up something from the room. So we'll add a command. So else if command is equal to pickup. Actually steal most of that content. We'll get what we're picking up. We'll call this guy picked up item, and we get the item from get current room, remove item. So we'll ask the room to remove the item from it. And then if the picked up item is a real thing, we'll say you picked up params. And then we'll say the student add item picked up item. Okay, so that should handle the picked up part of this. So just the inverse of drop. So pick up tells us what do we want to pick up. Compile this, run it. Items here, we'll look at our backpack. We'll go ahead and drop a machete. Then we'll head to the north. We'll go ahead and drop a running chainsaw. We'll head to the south. We see our machete there. Head to the north. We see our chainsaw there. If I type in backpack, we see Mr. Gonzalez has nothing in his backpack. It's an empty backpack. So what is he going to do? He's going to, let's head south. We'll go ahead and pick up machete. So it says you picked up a machete. So now if we say backpack, we see that we have a machete in our backpack. We head north and we say pick up a running chainsaw. And then we say backpack. We see that we have a machete and a running chainsaw. So, you know, we have everything that we need now. So now we'd run into Dr. Locklear's office and begin the begin the assault. So we didn't quite get to our boss fight, but you know, when we spent a little bit more time on this, we could add some combat into this. But any questions on that? So I think that gives us the solution to the homework. And if you were only able to get it working with a single string command, that's fine. Without the spaces and that kind of stuff. Okay, any last minute questions about the exam or classes for next semester in our last couple minutes?
Yeah, I gotta talk to you after about my scheduling and stuff, but that's it.
Okay. Yeah, so I can hang out in the room if you're available now.
Is 470 the class you build a programming language in?
Yep.
Okay.
How many of you, out of curiosity, are, I guess, raise your hand or something, are going to take 470 in the fall?
Not this fall, but next fall for me.
Okay.
Fall after, senior.
Is that because it doesn't fit in this fall, or what's the deal?
Yeah, I've got pretty much a full schedule, and I'll probably just do it with my senior seminar since I feel like it'll kind of work out better that way.
Okay, that's fair enough, as long as you've gone through the rationalization of it. Anybody else, I guess, not taking 470 in the fall? Maybe that's the easier question, because I'm expecting most of you to be in that class. Because like I said, I think it makes the most sense to take 470 in the fall with the understanding that your senior project in the following fall is going to be pretty heavy. And those two classes, I would say 470 is going to be a similar thing to 300.
I'm probably not, because I'm changing majors, so I'm changing to more of a IT major. So, and I already did. So.
Yes, you're doing information systems. So you don't need 470.
Yeah, that's pretty much it.
Yep. Are you doing?
I will take this practice though.
Sure. Are you doing it in the new major? You're doing information systems concentration.
That's what I'm thinking about. So
okay.
It's.
Yeah, because I think that'll probably benefit you because there's some less requirements for some other classes, so you'll have more.
Right. Yep.
Okay. Any other questions about anything? And I'll hang out, Clancy, to talk for a few minutes. Questions, comments, concerns, bribes. All right, I will get the prerequisite for 470. The prerequisite's 300. So you're in the class for it right now. So you've met the prerequisite. Yeah, Colin and Josh, both of you probably should take 470 in the fall, unless you're in a similar situation to Clancy, where it just won't fit in your schedule and you're going to take it alongside of senior sem, which is possible. I don't think that's like a horrible thing to do. Just you're in programming mode right now, so it makes sense to stay in programming mode. If I think 470 benefits you for all of next year in your senior year, where if you're taking it simultaneously with senior sem, it maybe is a little bit heavy that semester, plus then you don't necessarily have the background to use for your senior sem, something like that. But, it is what it is. I at least strongly encourage everybody to take it.
Would you?
Go ahead.
Oh, sorry. Would you say the time commitment for the homework for 470 is comparable to like the past programming classes?
I would say yes or less. What'll end up happening is I think you'll spend quite a bit of time, and it's probably gonna be fairly comparable early on in the semester. But after maybe the third week or something like that, it'll probably take you less time, because since everything's recursive in there, the total amount of code you're writing is significantly less. Your entire homework assignment might be, 11 lines of code or less. It might be like 5 lines of code. It's a very specific 5 lines of code, but still only 5 lines of code. So you won't have, these giant, 6 or 7 classes that you're juggling like we're doing here. So it's maybe a little bit more intellectually deep stuff, but I think once you get a handle on the new language scheme, which is pretty fun, I think your actual time commitment will be less. But you might not believe that for the first, 3 weeks or something, as you're using this brand new language and, everything feels crazy. But after you get the hang of it, I think it will be less. Does that make sense?
Yeah, thank you.
All right, any other questions? All right, I will see you when I see you. I'm around all summer, so if you want to hang out, do some VR gaming or something like that, or have any questions, let me know. But I'll have the exam up hopefully today, but if not today, sometime tomorrow, and I'll post in Slack that it's up, and then you just have to take it all in one sitting sometime between now and midnight next Friday. All right, I will talk to you later, and I'll hang up, Clancy.
Littman, I was pretty